Hey there, Science Explorers. Welcome to today's lesson. Today's lesson is secret colors. Our objective today, Science Explorers will investigate to understand separation procedure of paper chromatography to reveal the true colors of color-coded candy pieces, watercolor markers, and Kool-Aid. Our science vocabulary today, chromatography, which is the process of separating mixtures of a gas or a liquid. A mixture is actually two or more things that are mixed together, but not chemically combined so that they can be separated from each other. So think about like if you're mixing something together and you could still take it apart. Whereas like say if you bake something, usually that's a chemical reaction. And when you mix those batters together, you can't. So soluble is a substance that is able to be dissolved, especially in water. A solvent is a substance that dissolves another substance. For example, if you mix sugar and water, sugar is the soluble, water is the solvent, okay? The solute is typically a solid substance that can be dissolved into a liquid. In the example of sugar and water, sugar is the solute, and it can be dissolved. So, again, let's talk about what a mixture is. What is a mixture? Well, a mixture is when two or more things are mixed together and they can be separated. They are called a mixture. This is because the molecules and atoms of a mixture are not chemically combined or linked together. Here are some examples of different types of mixtures, kind of like cereal and milk. Although if you let the cereal in there too long, it'll get soggy. But still, no chemical change there. You can separate the cereal and the milk. Soil, which contains things like dead plants, minerals, clay, water, etc. That's a mixture. Vegetable soup. All right, vegetable soup. It contains many different kinds of vegetables. It also has like a broth or a liquid. Even air. Air contains a combination of gases. Mixtures can be any combination of states of matter. So let's review the three most common states of matter. We have our solids, we have our liquids, and we have our gases, right? Cereal and milk are a mixture. Who else can think of what states of matter, or what states of matter are cereal and milk? Well, we have two of them. Okay, we have cereal, it's crunchy, typically. Okay, that's usually a solid. And then what's our milk? So our cereals are solid. Our milk is a liquid. That's right. What other kinds of mixtures can you think of? Go ahead and pause the video. Take a couple seconds. Talk to a neighbor. Talk to a friend. What other mixtures can you think of? Hey there, Science Explorers. I'm here with my friend Helium Hayden, and she's going to help me show you guys how we can separate a mixture. What we're doing here is we're going to take a mixture of, some of you might be like, ooh, snack time. If you remember back to the intro, we talked about separating cereal and milk. We talked about separating that solid and that liquid. And if you act fast enough, you can get the cereal out of there without it being too soggy, and you separate it. You could do that with your spoon. You could scoop out the cereal, or you can pick it out with your fingers. If your hands are clean, make sure you wash your hands. Moms, dads, I told them to wash their hands. But here's what we're gonna do. We're gonna model this activity with our party mix here. I don't know, should I be covering up the brand name, right? I have some on the plate, but I'm gonna put a little more there because I think you just need that extra work. Okay. Oh man, that one fell. Oh boy, I guess I gotta eat it. So here we go. Helium Hayden is going to model out separating. I'll help her for a little bit. I'll help her. Let's put some Cheetos here, right? We're gonna put the pretzels on the other side of the plate. You gonna help or you gonna eat? What are you doing?
Yum yum.
We got some yum yums. We got some different types of tortilla chips there. We got cheesy ones, and looks like non-cheesy ones. But yeah, so she's gonna keep separating. That's one way you can separate things with your phalange, your fingers. Think about this. Let's say you have a pile of rubber bands and paper clips. How could you separate those? What's an easy way you could separate those two things, right? You could take a magnet maybe, and magnet over the top, and it'll pull out those paper clips for you. What about separating salt and water? If you wanted to separate salt and water, you'd probably need to evaporate that water, okay? Helium Hayden's working very hard. She's very focused. I'm gonna eat her work.
How dare you?
Oh, I'm so sorry. I'm so sorry.
It's fine.
So we can separate, again, salt and water by evaporating the water, right? How can you get pebbles and sand separated? Well, you can run them through a sifter, right? Kind of like miners used to pan for gold. Sugar and water, again, is more of like an evaporation type thing, or recrystallization is what they call it. So there's different ways to separate. In this Science Explorers lesson, Helium Hayden's having a snack. She was supposed to have her snack at the beginning of the lesson. In today's lesson, we're going to talk about solvents and things that are going to help us dissolve things and separate things into their original ingredients, if you will. Kind of like Helium Hayden's doing here. Just in case you weren't into the party mix and you just wanted the Cheetos, Helium Hayden's going to sort it all out for you. Come check us out in activity number 1, marker chromatography. All right, this brings us to activity number 1, where we're going to talk about marker chromatography. Hey there, Science Explorers. Activity number 1, marker chromatography. What you're going to need for this lesson is you're going to need some markers, a pipette, 6-ounce cup of water with just about a 1/4 inch of water in it. We need 2 coffee filters cut into strips about 1 inch by 3 inches, and a plastic plate. So with our marker chromatography, you might look at these markers and you're like, okay, well, the brown marker has brown ink and the blue marker has blue ink. Well, what we're going to do is we're going to do a little science experiment to see if that's true. Okay, so what we need to do here is on one of your coffee filters, you're just going to make a blue dot, okay, with your blue marker. It's a primary color. It could have been any other primary color, any of the other 2 primary colors if you wanted to use them. And then the other one's going to be a secondary color. We pick brown. So we have brown and we have blue. And just make a tiny little dot. It's not even bigger than my fingertip. Okay. So now, what we're going to do is we're going to use some water, and we're going to take our dropper, our pipette, and we're going to put a couple drops of water right there on that ink. Yeah, let's go 3. Why not? And then we're going to do the same thing with the brown. All right. So now what we're doing is we're going to watch and see what happens with this marker. Okay? So with that, you start to see the ink bleed out with the water as it carries it away. And what's happening is it's separating the inks. Okay? The blue is just staying kind of blue there, right? It bled out and it's just kind of blue. But as we look at the brown, you see that the brown is starting to separate into multiple colors, not just brown. There's a little bit of reddish out here around the outside of the rim. There's some, it's starting to look like it's turning a little blue. The longer we let it sit there, the more it's going to separate. Let me see if I can add some more light to this just to brighten it up a little bit. But you see that there's like a little bit of blue here happening. And then as the brown bleeds out, the colors are separating. So brown marker is not just brown ink. It's actually many different types of ink mixed together to make the color brown. And if you learned it in art class, that's how you make a secondary color. Okay. So what's going to happen is I'm going to move this off to our side. Okay, and just let it sit there and just let it continue to do its magic. We'll see if it changes in a minute. The next thing we're going to do is another marker chromatography project. So I'm going to take two different colors. I'm going to take a full coffee filter, and this time I'm going to take, I don't know, green and purple. And what I want to do is I want to make a simple design on my coffee filter. Okay. You just draw a simple circle. Make another one, purple. Let's just get real fancy. We'll make it a wavy line. Why not? Let's see what happens. I think we're good. So, next thing you're going to do, you're going to take your coffee filter. You're going to fold it in half. You're going to take that and fold it in half again. So now I have half and in half. We're going to take our water cup that we had from earlier. I'm going to take the point and we're going to stick it in the water. Okay? And when we stick that point in the water, we're going to let it sit for a couple minutes. We're going to pause the video, or I'm going to pause my video and let it sit for a couple minutes. And then we'll come back and take a look and see what happens. So here we go. What's happening right now is it goes up and it's starting to separate. We'll be back. Okay, Science Explorers, we're back. We got to let our coffee filter sit for a little bit in our cup. As you can see, some of our ink bled out into our cup, so don't drink that water. But here's our coffee filter. We watched as it went up, the water went up the coffee filter and then started to get to the ink. And what happened is it started to separate that ink. If you remember, I put down green and purple. Well, some of what you see here is blue, right? Blue's coming out of both the green and the purple. So it starts to separate that. I put no blue down on the initial piece of paper. Remember that a solvent is a substance used to dissolve another substance. In this experiment, what was the solvent? The solvent was the water, okay? Notice that the dyes in the marker moved through the filter, and some of them moved at different speeds and different patterns. And that's because the chemical makeup of the different dyes, that's what made that go differently. So what you're going to be able to do is you're going to be able to take your filter and set it aside on a paper towel to let it dry. Okay. I might have been able to let mine dry a little more, just because it was the pause in the video. And what you're going to do is you're going to take it and you can crinkle it up in the middle. You're going to take a pipe cleaner. I found the word for it. I knew it was a pipe cleaner. And you're going to wrap it around like so. I'm going to wrap this. And now you're going to make your own little butterfly. Look at that. Haha. All right. So I got a pretty pattern there and everything. Okay. So that's it for activity number 1. Let's go check out activity number 2. Activity number 2, nature's colors. Okay, Science Explorers. Activity number 2, here we are with nature's colors. What we're going to do is we're going to take something from nature and see if we can't separate its colors from and see what's going on here. We have here 3 leafy greens that we would normally eat. We have a souffle cup. We're going to be using some rubbing alcohol. We're going to have a souffle cup with a filter. We'll get to all of that. First things first is you're going to each get 2 to 3 leaves of spinach or whichever leafy kind of green your teacher is giving you. And you're going to rip them up into tiny little pieces and put them in your one souffle cup. So here we go. I'm really just gonna sit here and try to rip it up and really get them into tiny pieces. Okay. Like so. The smaller the better, I would assume. But yeah, there it is. I'm just doing all three at once. If you wanted to do one at a time, it's gonna take you longer, but might limit some of that sliding around. You want to rip it up into tiny little pieces, Oof. Daddy Dietrich likes to cook. I should have just chopped it. Should have chopped it up like a chef. What's for dinner? Salad. Daddy Dietrich made salad for dinner. All right, so there we go. It's all in there. You guys probably are doing a better job than I am. My stubby fingers. But there it is. There's my leafy greens. All right, your Science Explored instructor is going to come around and they're going to put about 2 tablespoons into your greens here. And now that my bottle of alcohol is open, I can put about 2 tablespoons in there. You ready? 1. We'll give it 2, and we'll call that 2 tablespoons. And why not give it 1 more squeeze? I probably should have measured. Don't follow my bad example. What's going to happen next is we're going to let this sit for 30 minutes. And while we let this sit for 30 minutes, we're going to go conduct another experiment. And then we're going to come back and we'll see what this is all about. You're going to be making a skewer with a filter attached to it. You're going to tape it to there. And you're also going to get a 9-ounce cup that's going to sit in there like that. So while we wait our 30 minutes, we're going to take a look at our next activity. Here we go. Activity number 3, Kool-Aid chromatography. All right, Science Explorers, activity number 3, Kool-Aid chromatography. What we're going to be doing here is we're going to take some of our Kool-Aid mixture. We already mixed it in with some water, and what we're going to do is see what kind of chromatography we could do. We want to see if we can separate and see what kind of colors are being used in our Kool-Aid that we love so much, right? We have our orange over here, although after stirring in some water and making it a nice little paste there for it, it looks kind of red, doesn't it? Yeah, it looks like the Kool-Aid man. Oh yeah. Over here, this sludge is our grape. It smells amazing, but it does not look so tasty, right? It's like a tar pit. Okay, so we have the same kind of setup we had in activity number 1, where we have 2 of our coffee filter strips, about 1 inch wide, about, that's several inches long. It could have been down to 3. We're going to take our Q-tip, okay? And with our Q-tip, we're going to go into our orange, and we're going to just make a little dot, or a big dot, of orange right there on the coffee filter. We're going to take the clean edge of our Q-tip, and we're going to do the same thing with our grape Kool-Aid, which again, you might be looking at it saying, that's not grape, that's black. That's like tar Kool-Aid. But it's not. It really isn't. I promise. Great. So, we have our dots there. We're going to take our pipette. We have our clean water here. We're going to do the same kind of activity we did in the first activity. The same kind of thing. We're going to take a couple drops of water into our mixture there. And watch it work. Check it out. We get to see the magic happen. As you can see, what was what was our a solvent in here? It was the water. Okay, the water again is breaking down our stuff, and check that out. It's happening before your very eyes. That grape Kool-Aid, I mean, it does kind of look black there, but as it separates out, you see what's happening. Some of that blue ink or blue food dye that's in there is starting to bleed out. Over here with our orange Kool-Aid, you can see that it is also, there's some reddish there. We saw that already. And then as it bleeds out even further, it kind of looks like a solar flare. It's like it's yellow out there. That's a really neat look, don't you think? Okay, again, let me see what happens if I shed some more light on it and get a nice lit up view of what it looks like. Okay, it's pretty cool. By using the separation procedure of chromatography, we were able to separate Kool-Aid into the individual dyes that make up that color. Pretty neat. All right, and again, our solvent there was just water. Okay, so now that we're done with activity number 3, we're gonna go take a look in on activity number 2 with our nature's colors and see how well our rubbing alcohol solution turns out. Okay, Science Explorers, we're back checking in on our nature's colors. We were able to strain out our leaves here, all right? And this is what we got. This is the alcohol mixture with the what turned out after 30 minutes of coloring. So what we're going to do is we're going to take our skewer that we taped on a filter, okay? We want to take the filter and we want to put it into the water. And believe it or not, we're going to take that filter, we're going to sit it in here for another 30 minutes. And we're going to check back in on it occasionally, but we're going to let it sit for about 30 minutes and see what happens with our Nature's Colors activity. Activity number 4, how do different solvents affect chromatography? All right, Science Explorers, here's our next activity. We're going to talk about, or we're going to discover how different solvents affect our chromatography. So we have all of our setup right here. We have 3 different plates with the same pattern and the same markers. The variable is that on one we're going to use the solvent of water. On this center one, the Ca right here stands for citric acid. We're going to use for that one. And then on this last one, we're going to use alcohol. We want to see how these different solvents affect the chromatography of each one of these inks. So we're going to take our cotton balls, we're going to stick them in our solutions there. Okay, get them saturated. Get this alcohol one in there. Okay, and as those cotton balls are sucking up that that fluid, now I'm going to take it and I'm going to put it right in the center of our coffee filter. Ta-da. And then the alcohol one. Ta-da. Okay, so we're going to give it a couple minutes as we observe. This one was the water, and I do need to make note that these markers are water-soluble markers. They're washable markers. So if we're looking at this, okay, we see that our water one seems to be doing a better job at spreading our color, separating our colors here. The alcohol one, it's carrying some of our colors, but it's not really separating them as well as I would hope, I think. The citric acid is doing a decent job. Again, it's probably has something to do with the fact that we mixed the citric acid with water, so there is water in there. But here you have it. If you look at this, the water one is actually separating it a little more. The alcohol, like I said, I mean, there's a little bit of separation going on there. You can see some blues coming out and things like that, but it's not happening as quickly as it did with the citric acid and the water. And that's due to the fact that it's water-based ink. It's not soluble in the alcohol itself. What we can do is we can actually modify our experiment, and instead of, I'm gonna get a new coffee filter. All right, I'm gonna take this one off. I'm actually even gonna get rid of the cotton ball. Okay, I'm gonna put that on a paper plate for now. This new filter that I have, I tried to make the same design with different markers though this time. With the markers that I used, were permanent markers this time. So what we're gonna do is we're gonna take a new cotton ball, saturate it in the alcohol, okay? And we're gonna put it on there and see what happens. Okay. We'll see how that changes it. Yeah. Let's give it some time. Observe that it is doing something. Okay. Okay. This experiment shows us that permanent markers are not soluble in water, but they are soluble in alcohol. So alcohol separates out the colors that make up the permanent markers. It does a better job than water would on permanent markers. If we had used permanent marker on the rest of our filters, it would not have worked out as well as it did with our water one. Our water and our water-soluble ink definitely separates really nicely. Here's our citric acid. Okay, again, pretty good, but it didn't even spread nearly as far as our water did. Here's the permanent marker with alcohol, and it is separating, just again, not that fast. And then here is our water soluble with alcohol. Again, separated. I think the best one with the water soluble markers or the washable markers was obviously the water. Okay. Why did we use secondary colors instead of primary colors? Well, secondary colors are made of a mixture of colors, and using this process of chromatography, we're able to separate the colors and see the different kinds of colors that were used. Obviously, you can see some reds, some yellows, green. The green has the yellow and the blue coming out. Pretty cool stuff. All right. So we're going to go check back in on our other activity with our nature's colors and see if our solution is ready to do some chromatography with that. Activity number 5, candy chromatography. Yum. Here we are, Science Explorers. Activity number 5, candy chromatography. We get to play with some tasty candy, and if your instructors or parents at home say it's okay and you had clean hands, you might be able to eat some. Who knows? Shh, I didn't tell you that. Here's what we got. We have some water. This is just regular water. We have 4 coffee filter strips, and we have 4 different colors of, you bet it, some chewy, delicious, tropical tasting candy, Skittles. Okay, we're going to take a pipette, and we're going to take about 2 to 3 drops of water on each one of our Skittles over here. So we're gonna go 1, 2, ooh, surface tension, 3, let's just get crazy and go 4. Here's 1, 2, 3, 4. I feel like the surface tension of the green one was not as good. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So we're going to let that rock for a little bit. Well, about 30 seconds. We're going to let them sit in that water for about 30 seconds. Okay. What we're going to do from here is we're going to pick up the candy and we're going to press it to one of our coffee filters. Okay. I might even get, I'm going to try to do this. Ready? Here we go. Get that up there. Take it. So rub it, or press it down. Okay. And make it disappear. Wait. Oh. I'm going to wipe off my fingers in between each color so I don't contaminate the other colors. So we did red. Let's go orange. We'll go in the colors of the rainbow here. Okay. Rub it around, rub it around. Gonna press it down and make it disappear again. Ooh, it tastes so good. All right. Yellow. Rub the color. So some of the food dye coloring is coming off, obviously. And the last one. Green. Check that out. Mm-hmm. Pretty cool, right? So we got our little rainbow mix up here, right? Wiped off my hands, made the squished Skittles disappear. Now I'm going to use some rubbing alcohol to try to do our chromatography here. So get some rubbing alcohol. And we're going to put 3 to 4 drops of rubbing alcohol on each spot, right? So, here we go. Use a different pipette than the water one. I'm going to go 1, 2, 3. I always like to go crazy and do 4. And then 1, 2, 3, 4. All right. 1, 2, 3, 4. 1, 2, 3, 4. Ooh, almost 1, 5. Almost. Okay, so check that out. Okay, as we're sitting here observing, we see that it is starting to spread through, right? The color starts to separate into different bands. The colors of some of the candies are made from more than one dye. Those are typically going to be your secondary colors, not your primary color ones, but your secondary ones are definitely made of more than one dye. We use the alcohol instead of water because rubbing alcohol affects the dyes differently, and the dyes travel farther than it would have with the water. So, as you can see, it's going to start to separate. We can see some different colors, maybe some, but it definitely separated. I wonder what it would have looked like if we would have done a purple. It's always a good idea to go back and try. We're going to wrap up our lesson here with going back to our nature's colors and wrapping up that activity. Okay, guys, we're here to wrap up our secret colors lesson with our final activity with activity number 2, nature's colors. What we did was we took our leaves, we tore them up, we put them in the rubbing alcohol, if you remember. We let them sit for 30 minutes. Then we dangled them in our solution for 30 minutes. I let it go a little longer than 30 minutes, but it took mine a little longer to show up. So if you can come down here and take a look at what we did, again, I'll probably want to shed some light on this. So here we go. If you look really close, you can see that we did, from those leaves, start to really separate what we got there. That's our chromatography at work. It separated the pigments or the substances that give color in our spinach and our leaves and things like that. The pigments we can see in spinach leaves are carotenes, which are yellow. And if you look up here, you see the yellow line up there. There's a little bit of green and a little bit of yellow. That yellow is the carotenes, and the green pigment is the chlorophyll. This solvent we used was the rubbing alcohol. So, I mean, you could probably test other materials like leaves in, or rose petals or things like that, and you'll get different pigments that come out of those substances. You would just repeat the same process. But these are the pigments and the colors that we pulled out of our spinach there. We have the green for the chlorophyll, the yellow for the carotene. Okay, so that wraps up our lesson today for secret colors. I hope you guys enjoyed finding the different hidden colors that we were able to look for. Join us again next time for some more fun activities. And remember, here at Science Explorers, if it's not fun, we're not doing it.